Hey everybody, this is Christian, and today I'd like to show you my new self-hosted AI platform that I've recently deployed in my HomeLab. This is powered by the free and open source platform Ollama, which allows you to run many popular and powerful so-called LLMs, large language models, completely free at home with no internet connection needed and no data being sent to any cloud service. This is really great for privacy. And I've also deployed OpenWebUI, another free and open source project that functions as a web interface for Ollama and allowing you to use all these powerful AI models in a nice and uncomplicated way. By the way, I've also secured this entire platform with Traefik, my favorite reverse proxy, and Authentik to securely access the OpenWebUI platform and Ollama from any authenticated device in my entire local network. And of course, in this tutorial, I'd like to show you how I installed and deployed this. However, I also had a few problems with this project, and I'd like to talk about them as well. Because if you're building a local AI server, there are many pitfalls regarding the hardware requirements and virtualization. So I hope this tutorial helps anybody who's interested in this kind of project with some tips and tricks on how to get this up and running. But before we get started, I also want to tell you how I'm planning to access this local AI service securely from anywhere, because sometimes I might be traveling or I need to connect from a different network. And sure, I don't want to make it publicly available to anybody. That's why I'm using TwinGate, the sponsor of today's video. TwinGate is a zero-trust network access platform that allows me to connect securely to any service in my local network, no matter if I want to connect over SSH to manage my servers or if I want to access my local AI platform. TwinGate just works perfectly for that, and it is better than any traditional VPN because it is much simpler to deploy. It even works through NAT devices and firewalls without any port forwardings or firewall exceptions that you would have to configure. It is super smart, and furthermore, it is extremely secure. Because every access request that leaves my device has to be authorized. If it isn't, or something on the device looks suspicious, TwinGate won't let the request go through. If you would like to try it out, then check out my tutorials on how to set up TwinGate and integrate it into Docker, Kubernetes, or your DevOps environment using Terraform. It is a super cool project and completely free with up to 5 users and connect to 10 different remote networks. So start making your network more secure and accessible with TwinGate. Of course, I'll drop you a link to their website in the description down below. Alright guys, so now let's get into LLMs. First of all, I quickly want to talk about the project requirements here, because this is pretty important to ensure a smooth and fast experience when running LLMs at home. You probably have heard before that AI in general requires a lot of computing power and resources, especially a strong GPU, a graphics processing unit. And the reason why a GPU is much better for AI workloads is that GPUs are, in contrast to CPUs, better designed for processing multiple tasks at the same time. So CPUs are better for sequential processing, but AI workloads require a massive number of calculations simultaneously, and this is why it makes a lot of sense to run these kind of tasks on a strong GPU instead of a CPU. Now, when it comes to GPUs, there are two big players in the market you probably have heard about, and they provide a strong platform for running AI models: NVIDIA and AMD. NVIDIA's CUDA, the Compute Unified Device Architecture, is a parallel computing platform and API model that has become the gold standard for developing machine learning frameworks. And their GeForce RTX series isn't just a beloved GPU by gamers, it also offers a super powerful platform for consumers to run LLMs, especially the larger models like the RTX 5090 has a high number of CUDA cores, and the more CUDA cores the GPU has, the faster it can process AI tasks. In my opinion, this definitely seems to be the most popular option for running LLMs at home. I've seen that in many other tutorials on YouTube, but honestly, I was kind of shocked when I found out how expensive these GeForce RTX GPUs are, and honestly, this is just a little too expensive for my little project. I know what some people might recommend here: just get a used older generation like a GeForce RTX 3090 or something like that, and yeah, looking back, that probably would have simplified things for me. But actually, I was always a big fan of the underdog AMD, so that's why I've searched for an alternative to GeForce cards. And the cool thing is that newer AMD Radeon graphics cards also have their own competitive technology to NVIDIA's CUDA, which is called ROCm, Radeon Open Compute. And this is also now fully supported in Ollama, which is really great. So check out the official documentation page on the GitHub repository in Ollama. So here you can see a table showing you which graphics cards from which manufacturers work with Ollama. Of course, I will leave you a link to this in the description. And as you can see here, many of the NVIDIA graphics cards are supported, of course, even down to some of the older models. But also on the AMD side, you have plenty of options from cheaper models like the 7600 up to the bigger and stronger 7900 series. So I've decided to buy the AMD Radeon 7900 XT because that one costs about 760 euros and it has a lot of VRAM, 20 gigabytes. And that is amazing because an NVIDIA card with that amount of VRAM would cost much more. And the reason why you should care about the amount of VRAM is that the larger the model is, the more VRAM you need to load it into the memory. For example, on the Meta's documentation page, you can see the smaller 7B Llama models. There you need at least 8 gigabytes of VRAM. For 13B models, 16 gigabytes. And for 70B, you would need 64 gigabytes, which is, by the way, not in the scope of this project. So my hope was that with the Radeon 7900 XT, I would be able to load a 13B model plus a smaller 7B model at the same time, which, by the way, definitely worked. You will see in my test later. So in my opinion, when getting an AMD graphics card, you get a lot more for the money. Actually, I've never owned such an expensive graphics card, so this thing is a huge monster. It is so big that I even needed to get a different rack server case to put it in. And by the way, I'm also working on a second video showing you all of these hardware upgrades that I needed to make to my home server where this AI stuff is running on. So if you don't want to miss that, make sure to subscribe. And if you already hit that subscribe button, well, you can also give it a thumbs up. That would be really nice. Now let's also talk about the software project planning, so Ollama and the operating system to run this thing on. Ollama, again, is a free and open source application or platform that allows you to easily get up and running with large language models. It is available for macOS, Windows, and Linux, so you can run this thing on any OS. And the cool thing, it also has an official Docker image. So how you install and set up Ollama is basically up to you. In this tutorial, I will show you the one and only way that worked for me, but just that you know, there are different possibilities and different ways on how you can install and set up this thing in your environment. Ollama supports a huge list of LLMs developed by different organizations like the new and famous DeepSeek R1, which was pretty popular in the news recently. It also runs the Llama model developed by Meta, Microsoft's 5.4 and Google's Gemma. On the official Ollama website, you can find a complete list of all of these models it supports, and it's continuing to adding more because all of these AI models seem to be very unique. Some of them are specifically designed for just one task, which they are extremely good at, better than others. And others are more suitable for general usage and can do a variety of things. So you really have to try out which model performs for which type of action. Honestly, I can't really tell you right now which model is the best for which task, because hands down, I'm kind of late in the AI game. I know that, and I don't have that much experience. So that's what I'm definitely going to work on the next month. So I start experimenting with it and see which model performs best in which type of task for me. Alright guys, so let me show you how I've installed this Ollama thing. So my first attempt was to install a new virtual machine in Proxmox using Ubuntu 24.04 LTS and use PCI pass-through to get the AMD graphics card hooked into the virtual machine so it could be used by the Ollama application. I've installed the AMD graphics drivers and the ROCm drivers, but for whatever reason I always ran into the same problem that the virtual machine would hang in some sort of deadlock state where I needed to restart the entire Proxmox host to get it up and running again, and it never really worked for longer than just a few seconds. And guys, honestly, I spent hours and hours reading through different Proxmox forum posts and trying to adjust settings in the group bootloader, blacklisting AMD GPU drivers and whatnot, but for whatever reason, no matter what I tried, I just couldn't get it working. And that's why I tried out a completely different approach for this project. Instead of using a virtual machine where I needed to pass through the AMD graphics card using PCI, I thought maybe it would work in an LXC container. And that was actually the setup that finally worked for me. However, I have to admit, when I was preparing the recording for this video, someone on my Discord told me there was something I hadn't thought about at this point. And by the way, thank you Soldat86 for mentioning this, because when you want to pass through a graphics card into Proxmox, there may be some additional steps that you have to follow to get this working, and they can differ depending on what manufacturer and what specific GPU model you have. Especially AMD graphics cards, they seem to suffer from a so-called AMD reset bug, and probably that's what I was running into. And some GPU models might require attaching a specific ROM file into the virtual machine's configuration to get your graphics card correctly working inside the VM. And that's what I haven't tried out yet. Probably this is the case for my graphics card that I've got, and I just need to do that. But again, I just found out after doing this project. But I will definitely spend a couple of more hours testing and trying it out, and maybe I'll do an updated video once I figure out how this works. But for this tutorial, let's just accept I had to go with the LXC container approach that worked for me. So let me show you how I've done that. So first, I've installed a new LXC container on my Proxmox node where the AMD graphics card is plugged in. I think it is important to set it up as a privileged container. I also use the Ubuntu 24.04 LTS template for the LXC container. This seems to be the operating system where the AMD ROCm drivers are the best supported on. I also gave it a huge disk size because I need a lot of disk space where to store the larger AI models on. And now for the networking settings, I connected this LXC container to my local production network using the VM bridge, just like I do it in a VM, and then gave it a static IP address of my network so that the OpenWebUI that we are deploying later in a Docker container and also my VS Code extension can connect to this Ollama application just using the local network. And note, this is kind of a work in progress thing here, because actually I didn't want to expose the LXC container and the Ollama application directly to the entire network, because Ollama itself has no HTTPS and no authentication, and this, in my opinion, is of course a problem. So it's fine when you're running Ollama just on your local machine or inside a local Docker network, but if you want to make this available to your entire physical network, that is not a great setup. However, because I'm using an LXC container and not Docker to run Ollama, I couldn't easily expose this via Traefik like I usually do. So I did follow a different approach. I used a different Traefik instance on my other Proxmox node to expose the Ollama application with trusted TLS certificates and a secure authentication using the Authentik middleware. But I will show you later how exactly that's working. First of all, let's continue with the Ollama setup. So once I had created the LXC container, it is also important to pass through the AMD graphics card, of course. And there's a kind of another workaround that I needed to find to do that, because it is a little different from the PCI pass-through in a virtual machine. Because instead of selecting the graphics card from the drop-down menu, you have to give it a device path. And there are two device paths that you need for an AMD graphics card to be passed through: the /dev/kfd and the /dev/dri. The first one worked, but for the second one I unfortunately got an error. Luckily, I found a solution in another Proxmox forum post to that as well, so I needed to go into the CLI of Proxmox and I needed to edit the LXC containers config file, adding these 4 lines here. So these lines ensure that the AMD graphics card is correctly passed through to the LXC container. Once I'd done that, I just logged into the LXC container and I did some basic setup tasks like updating the apt packages, adding an administrative user, copying my SSH key to that user, and then installing the AMD drivers and the ROCm drivers. Now, I'm not going through all of these steps in detail here. I think at some point I just need to make a dedicated tutorial about LXC containers in Proxmox. I think that was even requested by some of you guys in previous videos. And for the AMD driver stuff, I just basically followed the steps that are described in the AMD documentation. So just copy and paste this stuff. I will link you the documentation page that I've used in the description of this video. Alright, so once I had installed and rebooted the LXC container, I checked with the ROCm info and ROCm SMI commands to see if the AMD graphics card was correctly detected inside the LXC container. And as you can see, this finally worked. So both the LXC container and the Proxmox host were just running fine without any problems, and I could finally install Ollama. Luckily, the Ollama installation itself wasn't too hard, so I just used the installation script from the Ollama homepage, which was pretty simple and straightforward. There was just another small problem, and that is that the Ollama application is usually creating another Ollama user where it's running with, and this user wasn't able to detect the AMD graphics card because it was not running as root. I suppose it has to be some problem with the LXC container and the driver's pass-through method with the /device. However, to be honest with you guys, I was just so sick of this AMD pass-through stuff at this point, and I just went into the systemd service settings and changed the user and the group of the Ollama service to root, restarted the daemon, and then the Ollama application could find my AMD graphics card and the setup was working. Now, before some of you guys will get angry and typing in comments right now, I know this is kind of an insecure setup, right? So I'm running a service that I expose to a local network without any encryption, without any authentication, and it is running as root. So worst case scenario. I know this is a huge problem, and it's probably not a setup I would use in a production environment. I'm very aware of this, okay? However, I just couldn't find a better way to do it with what I had in my HomeLab. And what I've done to at least mitigate the risk to something that is, in my opinion, acceptable. Although I allowed Ollama to listen on any network interface it's connected to, I restricted the incoming sources using the UFW, the uncomplicated firewall on Ubuntu. So this I just configured in a way that only the IP address of my application server can connect to the Ollama's networking service. And on this application server, I'm again running Traefik, where I've configured Ollama as an external service using a file config provider, which effectively means you can only connect through Traefik from this specific application server using trusted TLS certificates to Ollama. And of course, I've also added an authentic middleware to this configuration to lock it behind an authentication. So for example, when I want to connect from my Visual Studio Code extension from a different machine to the Ollama service, I have to use the API endpoint on the application server using HTTPS and providing a basic authentication header, a username and password string to be able to access it. As I said earlier, I know this isn't the ideal setup that I had planned originally. Of course, it would have been just better if I would have figured out how to pass through the AMD graphics card into the virtual machine in Proxmox, so then I could have just simply deployed Ollama in a Docker container inside the VM and then use Traefik labels, just like I usually do, to not have to expose it to the entire local network. However, I'm also kind of happy that I could find a real use case for an LXC container for the first time, and that also inspired me to make at least 2 more videos, one about LXC containers and the second follow-up video on PCI pass-through in Proxmox. Let me also quickly show you how this setup is working. So when I connect to the LXC container on my Proxmox node, I can just use the Ollama command to communicate with the Ollama service. So here you got a few commands how to just pull down another LLM, so a new model. You can also list any models that I've currently downloaded and installed in this Ollama instance. You can see I've downloaded the DeepSeek R1 model, Qwen from Alibaba's cloud, Qwen Coder, that I use a lot for coding tasks and so on. The Llama 3.2, of course, and Microsoft's 5.4 I'm also testing from time to time. So you can see how large these models can get, so you definitely need some disk space to store them. And of course, you need to also load them into the memory. So for example, the DeepSeek R1 32B barely fits into the AMD graphics card with 20 GB of VRAM. But you can, for example, still load a smaller model. For example, if I want to run Qwen with 7B, for example, let's generate a small Python script. You can see how fast it's generating the text. When I open a different command, you can see with the Ollama PS command, you can see what model is currently loaded. And you can also see if the AMD graphics card is detected by Ollama when the processor is set to 100% on GPU. So then the model will definitely run much faster instead of just processing it on a CPU. Let's just run the Qwen model with 13B. It's 14B, sorry. Then Ollama is smart enough to shut down the older model, and when it still has some VRAM left, it can also run these models in parallel. So for example, you can see currently both models are loaded into the GPU's VRAM, one with 11 gigabytes and the other one with 6 gigabytes. So you can see that's generating a bit slower because the model is a bit larger and probably a bit more intelligent, but it also requires more resources. All right, so yeah, that was my long and complicated story on how to set up and run Ollama in my HomeLab. Hopefully it helped somebody who is using an AMD graphics card and maybe you want to use Proxmox and you don't know how to do that. Or maybe it convinced some of you to just buy an NVIDIA graphics card to do that, right? Now, let's talk about how to actually use the AI models in Ollama and how to interact with them. Because honestly, you can use terminal commands to do that, but it's probably not the most comfortable way. That's why many people will use OpenWebUI, which is an extensible self-hosted AI interface that can adapt to your workflow while running entirely offline. By the way, you can also connect different AI models in the cloud like ChatGPT and stuff if you got an API token and so on. But if you're just using Ollama, you can work with this entirely offline. You can also find this project on GitHub with some great documentation and examples on how to get it up and running. It also has many advanced features, code execution for Python. It has web searching built in. You can create your own AI models that you can extend with Python functions. Again, I'm not an expert in this, and I probably just use the most simple features that I'm going to show you in this video. But just know that if you deploy OpenWebUI as an interface to work with Ollama, this gives you so many possibilities to extend in the future, and in my opinion, it is so much more powerful than just the regular web interface of OpenAI's ChatGPT, for example, so you can really do a lot with this stuff. But let's go through the installation. So when you go to the official documentation here, you can see a guide to quickly get started with that and install it using Docker. You can even deploy it in Kubernetes, yeah, or you use Docker Compose, Podman, Docker Swarm. So there are many great tutorials. However, if you've watched my videos, you probably know that I'm a big fan of my own templates, yeah, that I collect in a Git repository called Boilerplate. So here, when you go to Docker Compose, you will find a new project for OpenWebUI. So this we can easily use as a template. Here you will find the Docker Compose file or the Compose file you can use with your favorite container engine. So I'm just going to copy everything. And then we're going to deploy a new instance. Of course, we're not deploying this in the LXC container where Ollama is running. So if I would have deployed this on a VM and in a Docker container, then I could do it. But of course, in the LXC container, I've not installed the Docker engine. And I think this is even not recommended by Proxmox. So Proxmox says, if you want to use the Docker engine, then it's better to use a virtual machine and install the Docker there and not use an LXC container. So we will just exit from this. Here, Ollama is running and we can use it, but only from the IP address of my main application server. So I will open a new connection to that application server with this IP address, and I will create a new directory that I just call OpenWebUI demo 1. So this is what we can use for this project. And of course, I don't want to work with terminal editors. I will just use VS Code for that. And with the remote extension, I will just connect to my remote server. So then I will open the project directory that we've just created, and then we can work on this just like I would do on a local project directory. Okay, so in here we will create a new compose file for the Docker engine and paste everything from my templates. So of course we want to customize a couple of settings here, and let us go through this one by one so you understand what we're deploying here. First of all, we want to deploy a new container with that image here. So this is the image from the GitHub registry for the OpenWebUI project in the latest version. I think the latest version now is 0.5.16. All right, I also like to give my containers a name. This is optional, but usually I set this as the same name as the project here. And what I also want to get rid of is this ports section here, because I just prefer exposing any web servers securely with HTTPS certificates and the Traefik reverse proxy. By the way, if you haven't heard about Traefik before, you're not familiar with this, you can expose the ports directly, but just know that the connection to the OpenWebUI service is not encrypted then. So therefore, I would definitely familiarize myself with Traefik. By the way, I've made a tutorial. I will link you that in the description, so we will get rid of the port and instead use the prepared Traefik labels that I've created here. And what I also don't want to do is use the Authentik single sign-on with OpenID Connect. So I've explained this in my first Authentik videos. With this, you can enable single sign-on so that you don't have to create new users for OpenWebUI. You can just use the existing users in your Authentik directory, which is pretty cool. Of course, I will also link to that in the description. But for this video, we are not going through this. We will just use the local user authentication in OpenWebUI. The only thing that we need to customize here are the traffic labels and the Ollama base URL, because that you can configure to automatically connect OpenWebUI to your Ollama instance. And if you would be running Ollama on the same server where you are deploying OpenWebUI, also in a Docker container, so then you can just refer to the internals Docker network container name. But in my case, I'm not running this in Docker. I'm running this in the LXC container on the secondary Proxmox node. So what I have to fill in here is the IP address of the LXC container that I've configured in Proxmox, in my case the 10.20.0.20. And of course we also need to store the data for OpenWebUI where it's generating the users. It also stores a history of your chat windows and stuff. So make sure to add this to a Docker volume here. I just created a new Docker volume called data in this project compose stack, then mounted this into the app backend data directory with read write. So this is where OpenWebUI stores its data. Of course, I want to connect this to my Docker network front end. So this is Docker network where the traffic reverse proxy is running. And these labels just work right out of the box with my certificate resolver that I've configured in Traefik. And here I just need to change. I think I will give it a different name because I think my production OpenWebUI system is using this label. Let's just call it OpenWebUI demo. And then, of course, I can use an FQDN. For example, let's just call it OpenWebUI/demo1. And then my server production1.home.ccreative.de. So this DNS record will be forwarded to the IP address of my application server. All right, and I think that is everything. We don't need anything else. So let's go back to the terminal. Let's see if the compose file is there. And then we can just hit a docker compose up/d to run it in the background. All right, so now it's pulling down the latest updates and starting up the OpenWebUI container. All right, so now OpenWebUI is up and running. We can check with the docker compose logs if there are any errors found in the logs. This indicates that the service should be up and running. It probably takes some time until you can access the web UI, so be patient, wait a minute or two, and then you should be able to open the web UI using the IP address and port number or just the FQDN that you've defined in the traffic labels. So let's just open this in a new private browser window. And yeah, so here we can log into OpenWebUI, click on Get Started. And first of all, you will have to set a new admin account. So just enter your full name if you want, your email address if you like, and a strong password. All right, and then we are logged in. We can now use OpenWebUI. So first of all, I want to show you around. And so here in the left window, you can find your AI chat windows and your chat history. You can also click here to your user account and go into settings. So here you can configure a couple of things like the theme, dark mode or light mode or whatever. Oh, there's a her theme. Oh my God. Okay, so let's switch it back to system dark mode. You can configure various things about the interface. You can connect direct connections to other API endpoints if you want to add ChatGPT or anything. And if you go to admin settings, so this opens a new window where you can configure the administrator configs of OpenWebUI. Like on connections, you can see your Ollama API connections. So this should be automatically added because we've created this environment variable with the base URL. By the way, if you've done any mistake here, you can still go in the web UI and change the settings in here. And here in the model section, you can start downloading new models. So as you can see, I've already downloaded a couple of LLMs to my Ollama instance. If you don't know how to do that, well, you can just go to ollama.com/library. So here get a list of all the LLMs in the official Ollama library. You can search for something specific and just download it when you go back to OpenWebUI and click on that Manage Model button here. pull a model from Ollama.com, just enter the name of the model. So for example, you can just pull down Llama 3.2 1B. So just enter the name in here, 1B. Just download, and then it's pulling down the manifest. You also see a progress bar when it's completed, and then the new model should appear in this list. So I'm not downloading it now. Let's just cancel it. So this is what I would recommend you to get started with. Just to give you some orientation about the different things here, so you can find Meta's Llama model. This is probably the easiest and the best model to get started with, yeah, because it can do a variety of tasks and comes in very small sizes as well. So it's very simple and fast to download. It's probably not the most intelligent model, but yeah, you can start playing around with this and use it for various type of chats, asking questions, code assistance and whatnot. If you go back, you also find Microsoft's 5.4, state-of-the-art open model from Microsoft, yeah, whatever you want to call it. You can also find the Qwen 2.5 models. So I really like these models a lot, although they are created by Alibaba's latest large-scale dataset, but it's pretty intelligent. This model is actually pretty good. It comes in a variety of different sizes. So depending on how much VRAM your GPU has, you can select what model is the most efficient for you. It also has a coder edition. So this is trained on code-specific Qwen models. So pretty great for code refactoring or getting assistance with your programming tasks and so on. And of course, there is the popular DeepSeek R1 model. So this is one of the first reasoning models that you can use. So the reasoning models are kind of a different thing. And I will go into detail in this in a second. I just wanted to show you what models you probably should get started with. Let's play around with this thing on my little test instance. Let me show you some cool stuff, what you can do with it. So let's switch to the model. Yeah, let's go to Llama 3.2, ask it a question. Yeah, there are some suggested things you can start. By the way, if you don't want these chat windows to be stored in the history, there's also setting temporary chat. So this is what you can enable. I will disable this so you can see how the chat windows pop up here in the history. And yeah, let's just use one of these example questions. Show me a code snippet. Yeah, why not? Let's do a technical task here. And you can see now it's starting generating some code. Again, because this is a pretty small model, it's generating the text very, very fast, right? And you can see OpenWebUI supports code blocks. Yeah, it supports syntax highlighting and stuff. So it's really, really amazing. And let's do a different thing. You can also load multiple models at once. So for example, let's use the Llama model and add another one and maybe switch to Quencoder. Let's also use the 7B model. Okay, so that's fine. And let's generate a new task. For example, create a simple Python for using the request library. So, and then you can see, because the Llama model is already loaded into my graphics card, it immediately starts generating text. Again, if I go back to my LXC container and execute the Ollama PS command, you can see that both models are currently loaded into the GPU and they remain for, I don't know what's the timeout, but for a couple of minutes. So the next result should be generated much faster for both models. You can also see how different these examples are. They approach these kind of tasks in a very different way. And this Llama model seems to generate more stuff, but I wanted to have a simple example, so I like the Quencoder result more. And then you can start using them. You can start comparing the models, what generates the better result in your opinion. Let's open a new window here and switch the model to DeepSeek R1 14B. So let's give it an interesting task here. I will just copy something that I've prepared, which is create a Python program that requires the YouTube API so I can check what was my latest YouTube video I've published and post it to Discord. Would be a nice task, right? So now you can see this is doing something different. It's adding a thinking box. And this is part of the reasoning task that the AI model does. You can see it thought for 19 seconds, which might seem a pretty long time. If you click on that drop down button, you can also see what it was thinking. And if you follow this, you can see that the reasoning model try to imitate some sort of human thinking process, like an AI is trying to solve a puzzle, yeah, by piecing together clues and making smart guesses. It takes the information, finds out what makes the most sense based on the patterns it has learned, and then finally comes up with an answer that hopefully does what you wanted, right? So you can see, because it was thinking what I have to do, it provided me some step-by-step instructions for this task, like setting up a Google project and YouTube data API, setting up a Discord bot, by the way, which is pretty cool with references to the links and so on, install the required Python libraries for the Google API and the Discord, and then gave me a Python script example that I can, I don't know, I probably would not just copy and paste it and run it, but I can analyze and work on. And yeah, then we even have some future steps, how to customize and run this script and so on. So this is pretty amazing. So whenever you have to make like logical decisions or problem solving things, the reasoning model make a lot of sense, because they have this thinking process and they are able to solve more complex tasks. That's it about a short introduction. Let me also show you something else, what is also pretty cool, because the LLMs, they usually can just use the information that they have or that they were trained on. What could happen if an LLM would be able to search the internet? So to some people, this might sound like the end of the world, but it's actually a pretty cool feature. So if I go in here and go to settings and go to web search, so here you can enable web searching. And you can also select a search engine. So what is pretty cool, you can also use this search XNG, which is the local search engine. I probably have to do a video about it at some point, but honestly, it wasn't high on my priority list here. So maybe we will see when I have time to do it. But you can use other search engines like Microsoft Bing. DuckDuckGo is probably what I would use to get it just quickly up and running, and click on save. So then when I go back, let's open a new chat window and select one of the faster models. For example, let's pick Llama. I think that was loaded in the memory, and let's enable web searching. So then I can give it a different task, something like who is Christian Lemper. I don't know if the model was trained on me, but probably not. So it will need web searching for it. So here you can see it's generating the search request, searching Christian Lemper biography, and there are 6 websites that it searched. And here you can see Christian Lemper, also known as Seal Creative, okay, is a YouTube content creator and Lego enthusiast. 9.8k followers on his social media platforms. What? So yeah, I think I got like almost 10k followers on Instagram, TikTok, and these kind of platforms, but on YouTube I obviously have more. His primary focus creating content around HomeLab's technology, pop culture, whatever means pop culture, right? Often incorporating his passion for Lego into his work. That is not true, so it came up with something really weird. But anyways, here you can also see it used 6 websites, and maybe there's something in here that wasn't quite right or provided wrong information or outdated information to this result. Okay guys, so I think that wasn't really planned, but it creates a great segue into what I wanted to say at the end. And this is part of the reason why I personally didn't want to make AI-based content on my channel in the early days, because if you see the results here, you cannot trust an AI model, even if it's using web searching. It comes up with wrong clues, sometimes it uses outdated or wrong data, and the results that it came up with isn't actually correct. This is what an LLM was never built for. It was never built for providing correct answers. So even though it came up with some great code, I cannot trust anything in here. I have to manually check everything. And maybe there will be a point where AI models will be superior to humans at some point, but I don't see this future right now. So I see this as a tool. It is amazing for experimenting. It's helping me a lot for creating content, solving complex technical tasks, explaining topics, creating code, refactoring code, and these type of things. But I would say never solely rely on an AI model. See this as a fun learning project, and I will try to find out in the next months what would be the right angle to approach this type of content on my channel. How much I will approach it in the content, we will see in the future. But anyway, guys, I believe this video is already too long, so I'm going to stop at this point. I hope this video helped you a bit to get your head around Ollama and OpenWebUI, and it helped you to set up these things, to play around and experiment with AI in your home lab in a secure, in a private way. If you haven't done it already, make sure to like and subscribe for more content. Thank you so much for watching this video, and a big thanks goes out to all my supporters and channel members. you make all these free tutorials possible. And as always, I'm going to catch you in the next one. Take care. Bye bye.